Welcome to today's Dig-In video.
I'm Em, and I'm an interpreter from the Missouri Botanical Garden.
And I'm David.
Get ready to pull up your sleeves because today we are going to be digging into soil.
So Em, why are we talking about soil today? Why should I care about it?
Well, David, soil is what humans literally stand on. For thousands of years, humans have built entire civilizations on soil all across the world. Soil is critical for agriculture and it's used to make some building materials too. Not to mention, soil is important for plants that grow within it and the animals that depend on those plants.
Wow, who knew soil could be so important? I noticed though that you keep calling it soil. Isn't soil just dirt?
Actually, no. People often confuse soil and dirt. Scientists define dirt as soil out of place in the human world. The mud on our shoes is dirt, while the ground surrounding our plants is soil.
I guess I've been calling soil dirt my whole life. What exactly is soil then?
I am glad you asked. Soil is made up of four distinct components, or kind of like ingredients, as I like to call them: air, water, organic material, and particles of rocks and minerals.
Wait, soil isn't just made out of pieces of rock? There's also water and air in it too?
There is. Actually, a surprising amount of soil is made up of water and air. Say, do you have that jar of soil I asked you to get ahead of time?
I do. I have it right here.
Awesome. So, water and rocks and mineral particles each make up about 25% of the volume of soil. So, about half of the soil that you collected is water and air.
About half, 50% is water and air? With those proportions, they must do something really important inside soil. What are the roles of water and air?
Well, let's think about them one at a time. What do you think water does in soil?
Hmm. Well, most living things need water to survive, so just like I need water, I bet the plants and animals that live in the soil need it too. Water is also really good at flowing through things, so I bet when it travels through soil, it could help move nutrients throughout it.
Exactly. Water does all of those things. Water can also have different chemicals dissolved within it, making the soil resistant to change, such as changes to its pH or how acidic the soil is.
Wow, that's amazing.
It really is. So, what do you think air's role within the soil is?
Hmm, I think similar to water, most living things need air to breathe. So the organisms living in the soil would probably need the air to survive. But what about the plants? Couldn't the plants get enough air from above ground?
Well, they do, but they also need some air from the soil. Plants need oxygen to survive. While the green portion of a plant can produce their own oxygen through photosynthesis, roots are unable to. During periods of flooding, plants can die because the pockets of air in the soil become filled with water, and plant roots are no longer able to gather that oxygen.
Wow, water and air sure have really important roles inside soil. You mentioned another part of soil that I wasn't expecting, though. Organic materials. What exactly is that?
Good question. Organic material is made up of the living organisms found within the soil and the remains of organisms that used to live in or above the soil. Organic material makes up about 5% of soil.
5%? That doesn't seem like much. What possible role could organic material have with taking up such a small portion of soil?
It actually does a lot. Even though organic material makes up such a small portion, it does so many important things. Earlier, you mentioned that water can help move nutrients through the soil. But where do you think many of those nutrients came from?
Organic materials. I forgot that when organic materials are decomposed, broken down, they release nutrients throughout the soil. Those nutrients can then go to feed everything living inside of it. Is that why people add compost to plants in planting beds?
That's exactly why. Over time, nutrients can become stripped from the soil, so additional nutrients may need to be added back in. Organic materials can also help hold on to water for use by plants and other soil organisms.
That must be why I often see peat moss added into things like potting mixtures.
Exactly. Finally, organic materials can help bind small mineral particles together.
Wow, who would have thought that such a small portion of soil could have such a big impact?
Exactly. Now, the last component of soil is the part that most people think of, the small pieces of rock and minerals.
That's the part that came to my mind. I know that rocks and minerals, they can come in a lot of different types. Are there different types of rock and mineral particles inside soil too?
Great question. There are. Rocks and particle pieces can be sorted into three general categories by size: sand, silt, and clay. Sand particles are the largest, and clay is the smallest.
Now that you mention it, I think I have heard of sand, silt, and clay. I remember that the difference in particle size between them was really surprising. I had a teacher in the past that had a really cool demonstration to show how different each of those particles were. Would you like to see that demonstration?
Yes, I would.
As we just learned, the rocks and minerals that make up soil can be divided into three categories depending on size: sand, silt, and clay. Now, it can be a little hard to visualize the difference between those three just by reading about their sizes on a piece of paper. So here's a really cool demonstration to help show the difference between sand, silt, and clay. Let's pretend for a second that we shrunk way down to the size of one of those particles. Let's imagine that our table here is a sand particle. Sand ranges in size from 2 millimeters in diameter to 0.05 millimeters in diameter. Still really small, but large enough that you can see most particles just by your eye and feel individual particles with your fingers. Let's have our table represent somewhere in between those two numbers, so about 1 millimeter in diameter. The next size particle is silt. Silt ranges in size from 0.05 millimeters in diameter to 0.002 millimeters in diameter. Much smaller. So small, you're no longer able to see individual particles or feel them with your fingers. Now you need to have a tool like a microscope to be able to see individual particles. So if our table represents a sand particle, a silt particle would be represented by a bottle cap. Very small compared to the much larger sand particle. Next after silt is clay. Clay is the smallest particle that makes up soil. Clay ranges in size less than 0.002 millimeters in diameter. So if our table is sand, our bottle cap is silt, a clay particle would be about the size of a sprinkle. Very tiny, so tiny you can't really even see it with the camera. Let's take a closer look. Look how much smaller a clay particle is compared to a sand particle. Isn't it amazing? Who would have thought that there could be such a big difference between the particles that make up soil? I wonder what kind of impact particle size can have on how a soil behaves.
The size of a particle can have a big impact on how a soil feels and acts. Soils that have a lot of sand in them feel pretty rough. Sand particles also do not stick to one another and allow water to drain very easily. Silt particles are too small to see without a microscope or feel individually, so it's very smooth but not sticky, especially when it's wet. Clay particles are the smallest and adhere together to form a sticky mass when wet and hard clods when dry. Clay soils are able to hold onto a lot of water.
Wow, soil particles can have such a big impact on how a soil reacts.
Soils also don't have just one type of particle within them, but often a mixture of them. There's a pretty easy experiment that you can do at home to see what amount of sand, silt, or clay are in a soil sample.
I think I know this experiment. Can I show how you do it?
Please do.
Alright, here's our experiment. It's super easy and it's going to tell us something really cool about our soil. This experiment will tell you how much sand, silt, and clay are in your soil. The materials that you need for this experiment are not that hard to get a hold of. All you need for this experiment is a container that can hold soil and water without leaking. So you can use something like a salsa container, like a jelly container, a peanut butter container, really anything that can hold water without leaking. Next, you need soil. I went ahead and collected soil from 3 different locations by my apartment. I got soil right outside my door, I got soil from a nearby playground, and I got soil by a pond. I just want to see, is the soil the same across these different areas, or is it different from just a short little distance between them? Let's find out. Other materials that you're going to need is a bowl that you can get dirty, some water to mix in with your soil, and something to mix everything up with. So the first thing you want to do is you want to take your soil sample and put it into that bowl. What we're going to be doing now is we're going to pull out any leaves, any roots, any parts of plants that we accidentally collected with our soil sample. While you're going through, you can also break up any bigger chunks of soil that you have. Large chunks of soil are going to slow down our process. We want those particle pieces to be separate so they can get separated really, really easily. Don't worry about getting every single root and leaf out of your soil sample. It's okay if there's some smaller pieces in there. You just want to remove any really big pieces that might get in the way. Once you're happy with the amount of roots and leaves you've pulled out of your soil and how broken down you got in it, you're ready for the next step. So what we're going to do is we're going to take our soil, we're going to add it back into our container, and we're going to fill up our container about 1/3 to 1/2 of the way full. Once your soil's back in your container, you're ready for the next step. Now we're going to add in our water. We want to fill up our container pretty much all the way full. We want to make sure there's enough water in there so we create a mixture and not just mud. Next, we're going to stir everything up. You want to make sure you get any big clumps resting at the bottom, so keep stirring until everything feels nice and smooth. Alright, I've been stirring for about 3 minutes now. Everything feels nice and smooth. I don't feel any lumps at the bottom, so I'm ready for our next step. I'm going to put on our lid, and now is the hardest part. I'm going to have to wait 24 hours. During those 24 hours, that's when the science happens. So right now, our soil is mixed up with water, so sand, silt, and clay are all distributed throughout that water. Slowly over time, they're going to start to settle out, but they settle out at a different rate. So, after 24 hours, depending on what all is inside our soil, we should see bands of those different categories. I'll see you guys then. Alright, it's been 24 hours, let's check out our results. Let's start by looking at the soil sample I collected at the nearby playground. If we look closely, you can kind of see 2 regions within our settled soil sample. There's a lighter colored region at the bottom, and on top of that there's a darker brown colored region. If you look at that lower region, you can kind of see some larger particles in there, and it looks almost grainy. That lower region is the sand. The sand settled out of our soil mixture first, and then resting on top of it, that would be the silt. I'm not seeing a third layer on top, so this soil sample doesn't really have any clay in it. Let's check out another soil sample. Alright, the next soil sample is the one I got directly outside of my apartment. This one has a really easy to see layer of clay. If you look at the very top, you see a really light colored brown layer, and that's the clay that settled out at the very end. It's resting on top of it looks like a lot of silt. I'm not seeing a lot of that grainy region that we saw in our other sample collected from the playground. So this one, it looks like, has a ton of silt and just a little bit of clay inside of the soil that I collected. Let's compare it to the final soil sample I collected over by the nearby pond. And here we have my final soil sample. This soil sample is really interesting because I only see one clearly defined region in the settled soil. Unlike the soil sample that I collected from my apartment, I don't see a layer of clay at the top. I also don't see a layer of that grainy sand at the bottom like we saw in the soil sample I collected from the nearby playground. So it looks like this is just a ton of silt in this soil sample. So unlike the others, there's only one type of soil particle really in this soil sample. Wow, it's amazing how different each of my soil samples turned out to be. Even though I collected each sample a couple miles away from one another, none of them had the same result. It makes me wonder, what could the soil look like in another town or another state? or even another country. This experiment, though, is a really easy way to figure out what is inside the soil where you live.
Thank you so much for exploring soil with me today.
Feel free to try out the experiment at home and follow the link down below to download your own soil exploration journal.
Tell us about what you discover.
If you enjoyed this dig-in video, make sure to check out the Missouri Botanical Gardens' other dig-in videos, and look forward to more dig-in videos coming soon.
Happy exploring, everyone. Bye-bye.
Bye!